All right, section 5.3, problems involving limiting quantities, also known as limiting reactant excess reagent problems. The concept behind a limiting reactant is one that we kind of have to deal with that generally gives some people some issues. All the problems that we've talked about thus far have talked about or have basically provided enough of either or both reactants in order to make the optimal amount of product. But that's not really realistic. What's more realistic is that there will be one reactant that gets used up or consumed before the other one, and thus the reactant is going to limit the reaction. So the terminology that you need to get comfortable with is limiting reactant is present in a limiting quantity. Any reactant that is left over is considered to be excess. You have more than enough. This reaction has gone to completion when the limiting reactant is completely used up. So the limitation imposed by one of those reactants is going to say when the reaction is done. Now to illustrate that, we've got this right here. This limiting reaction, here's our balanced chemical reaction. Okay, so this shows us the perfect ratio. 1 mole of N2 reacts with 3 moles of H2 to produce 2 moles of NH3. Now, this reaction shows a total of 1, 2, 3, 4 N2 molecules. Okay, so you can kind of look at that as 4 moles or 4 molecules. And our number of H2, well, we've got 1, 2, 3, 4, 5, 6 molecules of H2. Now, if we look at our balanced chemical reaction, it was 1 mole of N2 reacts with 3 moles of H2. Okay, so now let's look at the products that are generated. Well, we've got this molecule right here, which would be our NH3. This is another NH3. We've got a total of 4 molecules of NH3 that are produced, and then we have an excess of N2. Okay, now let's look back at our reactants. Basically what we've got is this molecule of N2, and I just picked this one because it was closest, is going to use 3 of those H2 molecules. This N2 molecule is going to use these 3 H2 molecules. So that means this one and this one are simply in excess. They're left over. So, well, they're not involved, or sorry, they're not utilized in the overall reaction. So to address this sort of question, we have a process, and we have some steps that you can follow to solve a limiting reactant problem. Limiting reactant problems have quantities of 2 or more reactants given. Okay. So what you need to do is identify the limiting reactant and base all subsequent reacting ratio calculations on the amount of your limiting reactant. There are 3 ways in which to identify a limiting reactant. First, separately calculate the amount of product that could form from each reactant. This is the way that I like to do it. The reactant that produces the smaller amount of the product is limiting. Alternatively, you could divide the moles of each reactant by its coefficient. The reactant with the smallest quotient is the limiting reactant. Finally, find the amount of each reactant needed to completely use up the other reactant. Disregard the scenario that requires more of a reactant than is actually present. Now, these are all kind of involved ways to determine the limiting reactant, but it's kind of an involved process. But the good thing is, as soon as you identify that limiting reactant problem or limiting reactant, you're basically done with that problem. Okay, so here is an example. The first thing that we're presented with is our balanced chemical reaction. Our balanced chemical reaction says 2 moles of CH3OH reacts with 3 moles of O2 to produce 2 moles of CO2 and 4 moles of H2O. Okay, now this would be the information that would be provided to you. A hypothetical, 1.5 moles of CH3OH and 0.5 moles of O2. So method 1 has you use the ratio and method 1 shows you using 1.5 moles of your CH3OH, the amount that you're provided with, and you compare that to your moles of, using your balanced chemical reaction, your moles of CO2 that are produced. And you'll learn that it's 1.5 moles of CO2 that are ultimately produced. Okay. Now, what you also want to do to compare that, and remember, your aim is to find out which one of these gives you fewer moles, and that is the limiting reactant. The next one is you take 0.5 moles of O2 and you relate that to O2 and CO2. So you use that ratio from your balanced chemical reaction, and you find out that 0.5 moles of O2 will only help you produce 0.33 moles of CO2. Now, through method 1, by identifying this as the one that produces less CO2, that is your limiting reactant. Okay, so that's pretty simple, or it's pretty straightforward. The next method, you take the number of moles the number of moles that you are provided with. So reactant number 1 is CH3OH. You say 1.5 divided by the number of moles of that, and you get a ratio of 0.75. Okay, option 2, you take the number of moles of O2 and divide that by the number of moles in the balanced chemical reaction, and you figure out that is 0.167. And again, you are looking for the lower of the two quantities, and you see, oh, okay, well, this is 0.5 to 3, it's 0.167. Again, you're identifying O2 as your limiting reactant. Okay, so these are two different methods, but they come to the same conclusion. Now, let's go ahead and take a look at this problem, which, well, our question is, calculate the number of moles of reactants and products that are present after the reaction of 1.5 moles of CH3OH with 0.5 moles of O2 is complete. Okay, so we have our reactants of CH3OH, O2, our products, CO2, H2O. We know which is our limiting reactant. Our limiting reactant, just because these are the same quantities that we were provided with in the last page, we know that O2 is our limiting reactant. Okay, so before I even really get started, I can look at this and say, well, there is no O2 remaining. Okay, now I can say that because O2 is limiting, meaning that all of it will be consumed. Now, what I want to do after that is I want to set up simple ratios, because I can say that O2 is my limiting reactant, so 0.5 mole of O2, and I want to find out how many moles of CO2 are left over, or how many moles of CO2 are produced. So I will say, use my ratio of moles of O2 to 2 moles of CO2, and I figure out that that is, well, 0.5 times 2 divided by 3, 0.5 times 2 divided by 3 gives me 0.33 moles CO2 are produced. Okay. Next, I'm going to say 0.5 moles of O2. Again, this is the limiting reactant, that's why I'm making this decision. 3 moles of O2 will produce 4 moles of H2O. So 0.5 times 4 divided by 3, well, that's going to give me 0.66 moles of H2O. Okay, now the next one that I want to use is 0.5 moles of O2, 3 moles of O2 to 2 moles of CH3OH. Okay, now 0.5 times 2 divided by 3 is going to again give me 0.33. But what is that number telling me? This number is telling me the amount of CH3 OH consumed. And so the question is asking me if I have, so I started out with 1.500 moles of CH3OH, and I only consumed 0.33 moles of CH3OH. Therefore, I'm left with 1.5 minus 0.33, 1.17 moles of CH3OH. Okay, I hope that was helpful. We're going to break this lecture up into a couple different videos, so I'll see you in the next one.